So the next thing we want to talk about now that establish our HTTP connection is to check balances. Let's say we have a ERC20 contract and we want to check the balances of addresses there. So how can we do that? To check balances, okay, before that, let's first create a file called balances.py. You can use the command touch or you can use vim to do so. So you should write something like vim balances.py or touch balances.py. This way you could make your file. In this file, you will set up the Web3 provider, define the variables, sender address and recipient address, and retrieve the balances of these accounts using the web3.eth.getBalance function. You will then format the results using the web3.fromWay function and print the balances in your terminal using the print function. To run that script, you can use the command Python 3. You should make sure that you have Python 3 installed on your machine, and then the name of the script, whatever it was. So here you can see that they put the Web3 provider snippet here, define address variables here, and by calling the function getBalance with the specific address in the unit of ether and then translating it to way, we will have the balance of the sender and the same thing for the recipient. And to display them, we just print them out. So we kind of do the same thing with JavaScript, but with a different syntax. So to check the account balances before and after the transaction, you just need to create a single file. You can call it like balances.js. Again, you can use vim touch or any other command that suits this purpose. And after that, you can create the script for the file. And here's the code for the script. These two lines here add the Web3 provider. These two create address variables. And we need to define a balances function like this and get balance info in it by calling getBalance function, eth.getBalance function, getting the balance in ether and translating it to way. And yeah, by using console.log, we could actually print it out. So yeah, this was the JS version. The next thing we'll do is to send a transaction. So now that we know how to check the balance, we want to send a transaction and using the check balance function to get balance function to make sure if it works properly or not. So to send a transaction, we can begin with another script. You need to create another file, like for example, like transaction.py using the same vim or touch command. And within this file, you will import RPC gas price strategy to obtain the gas price for the transaction. Then you will establish the Web3 provider, define the sender and the receiver variables, including the private key for the sender account. The next thing you'll do is to establish the Web3 provider, define the sender and receiver variables, establish the gas price strategy using getGasPriceStrategy function, and create and sign the transaction. using web3.eth.account.signTransaction function and send the transaction using web3.eth.sendRawTransaction. You will then wait for the transaction receipt using the web3.eth.waitForTransactionReceipt function and print the transaction hash in your console. So let's take a quick look into all those stuff that I just explained. Here we import the strategy, gas strategy. We need to put this on top of all our scripts from now on to establish a HTTP connection. And here we define our variables, receiver and sender. I need to give a quick tip about this private key and address. So you could easily generate your address or private key. It's totally independent of the Ethereum network. It's just a hash value that you can generate by, I don't know, a few lines of Python or whatever language that you use. And then after generating them, you can put them inside double quotes and use them. We don't normally put private keys inside the actual code. To be more professional, you can put it inside a specific file that has been secured somehow, and then put the address of that file, or someone that's just reviewing your code wouldn't have the access to your private key. We can also do the same thing for the address. We don't need the private key for the receiver, definitely, because the receiver is just receiving the token. There's no need for the PK. Here we're signing the transaction using account.signTransaction function, and there are a bunch of fields that you need to fill to sign a transaction. Like, for example, the nonce is kind of important, because if you're not using the right nonce, your transaction would not get admitted by the Ethereum node or whatever blockchain system based on Ethereum that you're working with, like CFX eSpace. Gas price is kind of important. If this value is lower than a specific amount, you wouldn't be able to have your transaction getting executed. The rest of the field's values are kind of dependent on which transaction you want to do, how much value you want to transfer. After signing the transaction, nothing has yet happened. So you haven't yet sent anything to the network. So at this point, the network is not really aware of your existence. To actually send them the transaction, we need to use sendRawTransaction function, and to make sure that everything's fine, we need to wait for the receipt. This is not mandatory. We can just send the transaction and go deal with other stuff in our code. It's recommended to use waitForTransactionReceipt function to make sure nothing went wrong with your transaction, because sometimes transactions get failed, and this is the only way you could find out about it. I mean, not the only way, but one of the easiest ways to do so. And at last, you could just simply print the hash of your transaction, which is a unique ID for your transaction. So it's the same story for JavaScript. You need to create a file, .js file, and fill it with this code here. And each line basically does the same thing, but just in a different syntax. There are like little differences between these syntaxes. Like for JavaScript, you probably, for example, have a different name for the fields. You specify it a little bit differently, but the functionality is totally the same. This is how we can send a transaction.